Chapter 17, question 321. It is about esterification. So, which carboxylic acid forms only one ester? Okay, with molecular formula C5H10O2. So, in this question, right, what you're trying to find is, let's say number one, ethanoic acid. Ethanoic acid can react with how many types of alcohol to form ester with 5 carbon. Okay, and then from the alcohol that we use, we write the structure of the ester that will be formed. So if you can get only one structure of the ester with the formula C5H10O2, that could be the answer. Okay, if you get more than one, then that is not the answer. Okay, let's try with the first one, ethanoic acid. Now, ethanoic acid has 2 carbon. Okay, CH3COOH. Now remember, we want to get ester with 5 carbon. 2 carbon comes from carboxylic acid. That means alcohol that we use here must be a 3 carbon alcohol. I'll start with the simplest one, propan 1-ol. Okay, 3 carbon, propan 1-ol, CH2, CH2, CH3, and then the alcohol is bonded to this carbon. So you see, react these two together, we get an ester with 5 carbon, CH3, CO, okay, O, CH2, CH2, CH3. Now if you count the number of carbon, hydrogen, and oxygen, you will realize that it has this molecular formula, C5, H10, and O2. But is this the only alcohol that we can use so that we get C5H10O2 ester? No, the answer is not. Why? Because propan 1-ol can have other isomers. This is propan 1-ol. Okay, I can use propan 2-ol, 3 carbon alcohol also, right? Okay, what if I use propan 2-ol? Let me write the equation again. Okay, now I'll use the same carboxylic acid, ethanoic acid. Okay, but I change this 3 carbon alcohol to propan 2-ol. Okay, propan 2-ol means the OH is bonded to the second carbon. Okay, at the end, I actually get this type of ester, CH3, CO. Okay, bonded to this C. Sorry, the O first, then the C. Remove this H. Okay, now I have CH3. Okay, another CH3. And then here H. Now again, I count the number of carbon, hydrogen, and oxygen in this ester, and I realize that it is still C5H10O2. Okay, so ethanoic acid can form 2 types of ester, okay, with the formula of C5H10O2 because of the variety of alcohol that we can use. So ethanoic acid is not the answer, cannot be the answer because it gives us 2 different esters. Let's check propanoic acid. Okay, number 2. Propanoic acid 3 carbon, CH3, CH2, COOH. Now 3 carbon carboxylic acid to get an ester with 5 carbon. Okay, I need to react this with a 2 carbon alcohol, which is ethanol. Okay, then I will get an ester with 5 carbon. Definitely the molecular formula is going to be the same again, C5H10O2. Okay, you can try to count, yeah, but trust me, it will be the same. It is again C5H10O2. But since we are using propanoic acid, the only type of alcohol that you can use will be 2 carbon alcohol. And you know 2 carbon alcohol like this will not have isomer, because no matter how you change the OH to the other carbon, they are still ethanol. They're the same, right? So this will be the only type of ester that we can get from propanoic acid. So number 2 is correct. Let's look at the third one. Now we have butanoic acid. Okay, a 4 carbon carboxylic acid. Now since we are using a 4 carbon carboxylic acid and we want to get a 5 carbon ester, 4 carbon 4 carbons come from butanoic acid, so 1 more carbon from the alcohol. So the only alcohol that we can use here is methanol. And we will get a 5 carbon ester with the formula CH3, CH2, CH2, COO, CH3. Now again, trust me, if you count the number of carbon, hydrogen and oxygen, the molecular formula is still C5H10O2. And methanol, only 1 carbon, definitely no structural isomer. This is the only alcohol that you can use to make C5H10O2 ester from butanoic acid. So there's only 1 ester that we can get. Number 3 is also correct. So answer is C, because 2 and 3 only are correct.